Please welcome Robert, who will be talking about NixOS, a functional GNU Linux distro.
Thanks a lot. So my name is Robert. I'm very happy to be here. Just a quick show of hands. Anybody heard of NixOS before? Oh, anybody using it right now? Oh, that's good. If everybody had used it, you would know everything I was about to say. But I'm glad everybody has heard about it, basically. So yeah, I'll be talking about NixOS. And just to give you a background about who I am and why I kind of got interested in Nix and NixOS. So I'm working, my day job is as a programmer, and me, as I think many other programmers, run into the problem of working on several projects at the same time, where the different projects, of course, depend on incompatible versions of some compiler or some library. So you have to juggle these dependencies when you're working on your different projects. And many people solve this by using some kind of Docker solution, or some programming languages have language-specific tooling. Like Haskell World has this stack, which is quite nice, and it lets you work with several versions of the Haskell compiler quite nicely. But at this time, in 2014, I was working in Perl, which at least I didn't find a good way to work with different versions of Perl and different packages, Perl packages at the same time. So I was looking around for a nice solution. And eventually I kind of ran into a package manager called Nix. And quite soon I became a contributor with different packages, Nix packages. And eventually I started using the NixOS Linux distribution built on top of the Nix package manager. So let's start from the end. I hope to spend quite a lot of time doing a demo. But to do a demo of NixOS, I kind of have to describe what NixOS is first. And to do that, I have to describe what the Nix package manager and the Nix expression language is in a very overview kind of way. So I won't go very much into depth in any particular area. Feel free to grab me afterwards and we can talk specifics. So let's start with the Nix package manager. So let's focus on these two final words here, package manager, and kind of get a common understanding of what a package is. So for this talk, I'll have a quite simple definition of a package. It's basically a set of files inside a file hierarchy that you, if you want, you can package up in a tarball and send to somewhere else. And typically you want to unpack this and run or use the files inside this package. This set of files we build using some kind of instructions that I'll call simply a build recipe. And the build recipe basically tells you everything you need to know how to construct this set of files. So it includes, if you're building a program, you might need to find the source code of this program. So the build recipe will tell you that. It will tell you which other packages that this program needs to be built or to run. And it, of course, includes the actual instructions you need to run to build the set of files. So this is a very general definition. I think this would hold for pretty much any package manager on any Linux distribution. And in this respect, Nix is no different from any of those other package managers. But if I go back to the heading here, this purely functional part is typically not something you see mentioned when you're talking about package managers. And by purely functional, I mainly think of two properties that you typically would have in a purely functional programming language. And the first and simplest is the idea of immutability. So the idea is in Nix is once you've built a package, the set of files, you never ever change this set of files. Even if you've installed them on your computer and used them, you never overwrite them when you update the package, for example. And this is quite different from many other package managers. You run your apt-get install, and if you already have a version of the package you were installing, at some point during this installation project, you're overwriting the files from the previous version of the package. And of course, this is I don't know if I've used Debian for a long time, and occasionally you run into the problem where your installation fails in the middle, and you always get this kind of lump in your stomach when that happens. Fortunately, I really like apt, since it usually can rescue such situations. But Nix is quite different because this overwriting of a previous version never happens. You either have a package, the files on your computer, or you don't, and you never are in between. Now, so this might seem a bit mysterious, how can you actually do this? And I'll try to explain that a bit later. Just want to explain the second property I would characterize from functional programming that is applying to Nix, and that is the idea of determinism. So I was talking about this build recipes. So Nix treats the building process. When you build a package, it treats this as sort of like a mathematical function. It takes a build recipe and produces for you a package. And like any other, like in mathematics, if you give a function the same parameters twice, you get the same result twice. And this is a property that Nix tries very hard to hold. Of course, this property is also common with quite a lot of package managers. Debian has spent a lot of time on this idea of binary reproducibility. So the idea is that if you build a package twice using the exact same compiler version, same dependencies, and all other things the same, you will get a binary exact binary copy both times. In this respect, Nix and other package managers are also not very different, but Nix performs a step here that is quite unique, I think, in the idea that most other package managers identify a package by the package name and the package version. So, for example, you have on your computer Firefox version, I don't know what's it up to, 58 or something. Nix does not give a package this kind of identity. Instead, it gives it an identity computed using a cryptographic hash of the build recipe. So instead of getting a nice name like Firefox 58, you get a huge string, which is a cryptographic hash, which might seem a bit cumbersome. It might not seem very practical, but it gives us quite powerful consequences. So let me go on to the Nix store. So I was said that the Nix never overwrites a package. It does this by simply putting packages somewhere else than in /user. So it puts a package in something it calls the Nix store, which you can think of sort of like a key value store, where the key is the hashed recipe, so the identity of the package that I mentioned in the previous slide, and the value is the built recipe, like the actual set of files. And of course, if you change the recipe, you'll get a completely different hash, so it will be a completely separate entry in your Nix store. Now this might seem a bit fancy, like you're having some kind of super server running on your system to keep track of all these Nix packages, but it's actually just a directory on your hard drive. And we can easily see this So let me just skip. Let me be a bit more interactive. So I have, let's look here. So I have a folder on my drive. It starts with the root folder, and it's just /nix/store, and that's my Nix store. And then you have this huge gobbledygook, which is the hash, which we computed from the build recipe for a package called cowsay. In particular, the version 3.03 of cowsay. And inside this package, we have a set of files. And these are the files that just belong to this package. So we're never mixing files with other packages in this way. So I was showing these here. So this is basically the same view I showed in the slide. And of course, if I go into the bin folder inside there and run cowsay, I can say hello BornHack with an @ there, and it will run like a regular executable. Nothing strange about that. Of course, it's quite inconvenient to actually try to remember the hash of the package you want to run. So it's also possible to install packages into your user environment, and that's quite different from the typical package managers as well. Since we're never overwriting packages, we're never having like a global set of packages installed, Nix allows us to safely perform user-level operations in on the packages. For example, we can install a package into our particular user environment. So I'll run env, and let me just, before I write, let me excuse the user experience of this command line argument. There is work underway to improve the user experience of these command line arguments, but for now, so first I have to tell Nix from where I want my packages to be, or rather where my build expressions are, build recipes are. And this allows me to tell that I want to use the main repository of build expressions that Nix has. So basically it's a huge repository somewhere on GitHub that contains build recipes for different packages. So I'm just saying that I want this package repository. And then I can run like an install. And I have to say which package I want to install. So I want to install cowsay. This attribute is basically the name of the package in a human understandable way. So now we actually installed cowsay, and it should now be in my user environment. Hello, BornHack. Cool. Now you'll notice that when I installed, let me just say which cowsay. When I installed, it actually placed the cowsay executable inside my home directory. So my username here is ryc, so it placed inside my home directory a folder called Nix profile, which is basically just a folder or directory containing the packages I've installed into my user environment. And under here, it's basically just like any other, very similar to like the root directory of any other Linux distribution. And under here I have like a ton of different packages that I've installed for my user only. So let's skip this. So this point is then, let me go back here. So I have bin cowsay in my home directory, and I could run it. Let's see where that is. So you can see it's a bit tricky here, but basically it says that this is a link to a store path, to the store path of the calsay package, this particular calsay package, and the executable inside there. So you'll notice that this hash is different from the one I showed earlier. Let's see if I still have that one in the history. So the previous version I had started with mkk5. The version I installed in my user directories has a hash called mhfa. So these are completely separate packages. Even though that the actual version number of the upstream version number is the same. So there's nothing hindering us from having several different variants of the same package installed in our system at the same time. It's only in my actual user environment I can only have one package, one version of calsay installed in my user environment at the same time. But I can always access the other versions by specifying the entire store path. And that's basically what I wanted to show here, that at this particular time I had 4 different variants of the same calsay package. And the difference basically is what kind of dependencies. So there have been some kind of slight difference in the build recipe for these 4 different versions of calsay. For example, that in one you had a Perl of one specific version, and in the other one you had Perl in a separate version. I happen to know that calsay is implemented in Perl. Does that make any sense? These are a bit strange notions from a typical package manager perspective. So, and this is basically what I showed. So we have a user Simon that installs calsay in his environment and can run it and access it. But the different user Jane tries to access calsay in her environment and it's not there. Of course, Jane can run the same command and she'll get a calsay in her environment, and that may or may not be the same one as Simon's. So if Simon tries to install a calsay version with some kind of hack or some kind of vulnerability, it will only install in his environment. If Jane tries to install calsay, she'll get the vanilla calsay version without the vulnerability. And hence the safety of user operations. Yeah, so I typically don't have calsay installed, so let me just run calsay E. And that you say it's uninstalling calsay and I can no longer run calsay. So that's kind of Nix, the package manager in a nutshell, or in a bash shell. So let's talk about the way Nix describes packages and other things. It uses a language called the Nix expression language. And that's the language, it's a custom language developed just for Nix, which is basically a pure lazy functional programming language. It's not strictly typed or anything like that. It's quite simple, and it's basically a DSL for building packages with some extra goodies on top. So let's just, is that visible? Yeah. So just some very simple basics. The Nix operating the expression language allows you to operate with different kind of data. Basically, typically it's numbers, whole numbers, booleans. It's also possible to describe decimal numbers, but or floating point numbers, but you can't actually perform computations with them. At least you couldn't before. So it's very focused on simple operations. It has quite a strong support for string expressions. So basically we have two different types of strings, or two ways to express strings in language. It's this typical double quotes, and it also has this string interpolation. It also has this two single quotes. You open a string that can be spanned over multiple lines, which I try to show here. And that's basically it, except it's also nice to know about lists and attributes, yeah. So like I said, Nix is not strictly typed, so you're allowed to have lists of this form where heterogeneous lists. Lists are quite useful, and we'll see them in the future. It also has something called attribute sets. You can think of them basically like maps. Very similar in formatting into JSON. It just allows you to skip the quotes if you're having a simple key name that's not containing any strange characters like space. And you can dereference a key by using this dot operator. So I think this is not anything super strange. Since I said it's a functional programming language, there's a strong focus on functions, and that's very lightweight syntax for that. So by default we have, typically we're working with curried functions like in Haskell. So typically we describe functions with one argument which return a function, which may return a function itself. So in this case we have add that takes an argument, returns a function that itself takes an argument y, and then adds the result as the final result. And we can apply the function add to two values simply by separating them with the space. So nothing very strange here. Something that is very common in Nix expressions is the idea of a function taking an attribute set as argument. And for that there is a bit of special syntax that lets you deconstruct the attribute set as in your function definition. So nothing super strange here. Cool. So I think next one is a complete package description in the Nix package manager. And I think most of the things here we saw in the previous slide. So basically, this whole thing is a function. It takes the standard environment, like the standard build environment that contains your GCC and your typical build tools. It also contains an argument called fetch URL, which allows us to specify where we want this package tarball to be fetched from. And then we have three different dependencies that themselves are packages. So a package is a value inside this language now. So these three things are packages that are passed as an argument into this package description. So I won't go into super detail, but basically you have the typical things you would need when you're defining a package. You have a package name, like a human readable name, which is still useful instead of these long hashes. It says where you should get this package from, the tarball containing the source code. It says which kind of build dependencies do you have. In this case, the package config is simply a build dependency. It's not used at runtime. So if we're doing a cross-platform build, we'll actually use the build platform's version of package config, while this libav and libxslt is built for the target platform in that case. And then we have some typical meta information, like the homepage of this package, and some descriptions. So that's pretty much it for the Nix expression language. And now we can talk a bit about NixOS. And I'll do this very briefly here. So now we can see that it's quite simple to, on top of the Nix package manager and Nix expression language, create a distribution, Linux distribution. So the first step is to describe your entire system as a Nix expression. So in this case, I describe the mount point I have in my Linux distribution or Linux install. And I say that, okay, I want my host file to include this extra entry. And then I include a bunch of other things that it perfectly describes my system that I want to achieve. And then step number 2, we create a build recipe using similar to the package description I showed earlier to take this system description expression and create the actual files that all the different tools expect. So for example, my file system description should be built into a typical fstab file with the formatting that the mount tool, for example, expects. And our hosts file should be formatted as our resolving library expects. And this built into the Nix store, of course. So if you just run mount with these files in the Nix store, of course they won't see them because they are looking in the /etc/fstab. So step number 3 is to update our bootloader to include, make sure to update our bootloader to add an entry that when we select that entry, it will start our Linux system and run a script that will populate our /etc with links to the package we just built. So /etc/fstab will point into the Nix store. And now when I run mount, it will actually find this file and be able to do something sensible with it. And of course, step number 4 is we reboot our computer and hope it works. But the cool thing, if it doesn't, we tell our bootloader to reload our previous version of our configuration. And that we're pretty certain it works because we used it to describe our next version. That's kind of cool. So let me try to do some demoing. Is that okay? So I have here a virtual box, like a virtual machine. I basically downloaded this from the NixOS website. They have ready-made VirtualBox devices, I think they're called. And you can just download that and load it up and do some experiments. And I have one demo user, which is non-privileged. We can, for example, do the thing we did before. Nix packages, EA, say. And it did basically the same thing I did before. Hello, BornHack, with yet. Right? And in the second tab here, I have a root user. So the Nix expression describing our system resides in /etc/nix configuration. What? NixOS configuration. And right now it's super minimal. So the only thing it does is import a ready-made configuration that is provided to actually define our VirtualBox machine. So it includes everything we need to just create a basic VirtualBox instance of NixOS. So I can add whatever I want here now. So we can start let's install Cowsay globally, since it's a bit annoying to keep installing it in every user's environment. We can also install the tree command, since I might use that. So now I've declaratively described which packages I want in my system available for all users. And then I exit here, and then I have to, if I go back here, I'll uninstall cowsay from this version user, and now I don't have it. So it's not enough to just write in this configuration file .nix. We actually have to make this configuration active. And we can do that without having to reboot by running the NixOS rebuild switch command. So basically it will take the configuration I just worked on and build this directory I showed you in the slides with some extra fancy stuff, since my description was very basic. So you can see it. Let's scroll up. So it basically says it's building the system configuration, and then it's building a bunch of different files. So for example, it's building something called the etc.drv. So it's building our etc directory. And it's downloading a couple of things, like GNU make for some reason, LND, patch elf. And then it's updating the grub entry, so our bootloader is updated. So next time I reboot, it will actually load this configuration I just activated. It's setting up /etc, which is the step I showed you where it creates the symlinks into the Nix store. And that's pretty much it for what I want to say. So if I go in here, I should have cowsay hello installed. Now it's a bit annoying to have to say cowsay hello BornHack every time. So let's create a bash alias for that. Programs bash. Let's see, shell aliases, I think it's called. So, oops. So hello is equal to, I want to run cowsay, hello BornHack. I don't completely remember whether that option name is the correct one, but Nix will tell us. It's doing something. Okay, cool. So hello is not there. Of course, we have to log in. So let's just open a new hello. So we have our alias defined, and if we do cat bash rc in the /etc, it should include alias hello there, including some other stuff that is by default. So that's kind of cool. Now on a system, you typically want to run some kind of services. Like when I'm developing, I sometimes develop for Redis. And then I'll very easily add Redis. Let me do this like this. I enable the Redis service. Save, switch. Oops, I wrote the wrong thing. Services. So while it's building, let me just prepare the command I'm planning to run. So this one should have downloaded it. It created the Redis configuration. It's downloaded Redis, I see here. And if we see here, it says the following new units were started, redis.service. So I didn't say that NixOS is based on systemd. So that's the init and the service manager. So Redis command line interface is here now. So that's cool. And of course, since this is a complete programming language, I can do some other interesting things. So I can say the Redis port. I want to use a custom Redis port. And then a port, like a Redis port. Now I made this a variable since I also want to add a shell alias, Redis 8, for example. Redis, I think that's the way you specify Redis port. I think that's the way you specify the port. So this is a nice way to show that by having a single language, which is fairly powerful, you're able to kind of integrate different configurations for different systems and programs in a relatively natural way. So can coerce an integer to string, so I think that was here. Okay, so let me see, and then we need a bash again. Redis 8. Oop. 8. And now I've connected to the right port. So that's kind of nice. Of course, like I said, it's very easy to mess things up sometimes. So let's make a bit of a mess. File systems, I think it is. Device, no such device. Let me just double check here. Oops, that I got. So device file systems, yeah, it should be right. Anybody know how I get back to my... Oh. So this is a pretty bad situation. And I wouldn't feel very comfortable doing something like that on my regular... Okay, so this mount point is actually defined inside this VirtualBox demo.nix. So we have to override it, and we can do that by using a function from a library we can pull in. That says lib make force, and then we forcibly set this value. Just downloading a bunch of stuff. All right. So this is not very good. I don't know how many of you would be happy to do something like this on your typical Linux distro. And of course, running reboot afterwards. So now you see the grub load screen. So basically the default is the one I just built. And we're kind of stuck here. So what do we do then? We reset our system. Reset. And when we are in grub, we go back down to all configurations, and here is the history of the configurations we've used so far today. So the last one is kind of poisonous. Let's skip that one. The 8th one was the one I was running that when we were actually making the changes. So that one should be safe. And it doesn't seem too bad. All right, so it's kind of booting. And that's really reassuring when you're doing strange things to your system, let me tell you. So that's pretty much it for this demo. That was the demo. So just to finish with just some typical other projects that are in the wider ecosystem surrounding Nix. So these are all, in one way or another, using the Nix package manager. Some of them are using the NixOS infrastructure as well. So having a single description of your system is, of course, very nice when you're deploying to many different machines. You can have this description in a Git repo. You can push it out to different machines and run the builds there. And there are two nice tools for this. The oldest one and most mature is this NixOps, and it also allows you to provision systems like on Amazon EC2 or something like that. Morph is a nice tool that the Bibliothekscenter, anybody from there here? Dansk Bibliothekscenter, they developed this, and it's similar to NixOps, but a bit simpler and more straightforward, I think. NixDarwin is kind of bringing the kind of configurations you do for NixOS to the Mac OS ecosystem. Home Manager is a project I initiated a few years ago that lets you do a configuration of your home directory, basically your .files and your user services in a similar way as NixOS does for the system level. And Hydra is the CI system that NixOS uses, and it describes its builds using the Nix expression language. So just a very quick summary. So the benefits of this is that you have a declarative configuration language, which allows you to very simply keep it in like a Git repo or something similar like to that. Your builds are reproducible, which is very nice when you're trying to set up your new laptop to have the same configuration as your own one. You want to just run NixOS rebuilt switch, and you want it to run the same way your old laptop did. Atomicity, and this is relating to the idea that you don't have in-place updates, or at least avoid it to the largest extent possible. And as we saw, we can always have the possibility of rolling back our configurations. So fearless upgrades, very nice. So unfortunately, there are some drawbacks. So the learning curve, I think most people would agree, is quite steep. And you have to kind of dive in the deep end first. Not entirely, though. The Nix package manager can run on pretty much any Linux distribution and Mac OS. And I actually used it in that way for a long time before I used NixOS. So I recommend doing that if you're not wanting to change your whole system. And it's tricky a bit to package software that assumes the existence of like your typical file hierarchies. And the final one is that there's still a relatively small user base, but it's growing quite a lot, I think. And there are some people in this room. So I'm very happy about the way people receive the NixOS and the ideas behind it. So that's it for me. Thank you very much.
Yes, thank you very much. We do have time for a few questions, so I think you were first.
Hi. So you were able to mess up your configuration.nix and get an unbootable system and then restore an older system that did work. But you still have your broken configuration.nix. So how do you recover that one?
What I typically would do is go back to edit that and fix the problem. The number 9 there that was unbootable, you can just go when you're in the working version of the configuration, you can just say remove that version of this configuration.
Okay, but so you need to remember what the working one looked like or keep a backup? Like if you change something complicated and the system doesn't boot anymore?
Yeah, the configuration.nix is the same broken one, yeah. So you have to either keep track of what change you made to break it, and typically I think people have their configuration in some kind of source repo, like a Git, and then you can track which change you did. And you could even like doing like bisection or something like that to find exactly what change broke the system. I don't know if that answered your question.
Sure.
Like,
in your configuration file, you did not specify any version numbers. How does that work for a functional declaration?
a functional what?
Like, how does it determine the version numbers while still being functional?
Well, depends on which version number. You mean like the upstream version number. So in Cowsay I had 3.03. And that is described in the package. So, so in our package description, in this package is called onPaper, and this is the version of this, the upstream version number of this package. Of course, I can change this version number, and then I'll get a completely different hash inside my Nix store, so a different version of this package. And then I have to actually install this build recipe to get this in my user environment, the updated version.
So how would you update a package in your NixOS configuration file?
In my configuration file, I basically, let me just go back here. Where did my terminal, I just booted. Terminal. Oh no, it is a NixOS configuration. So here, I actually didn't specify which version I wanted of Cowsay package, right? So the packages, so this is a huge attribute set of different packages, and the Cowsay attribute or value inside this is, let's see, is one of these things. So it will say which version it is. And when I update this huge package set, which I do by basically pulling it from the, for example, from the GitHub repo of all the packages, then I'll get the new version by definition, basically. And when I next rebuild my system, it will go into this new version of my package set and see that this is 6.2 now, and it will install that version. So yeah.
So you said that the hash in the path to the Nix store is a hash of the recipe?
Yeah.
But not actually a hash of the build?
No. So it's a hash of the recipe or the build instructions and all its dependencies, but it's not a hash of the files that you built.
So where are the hashes of the package itself then? Like if the reproducible builds failed and you had two different builds of the same recipe that actually had different content, like where are you?
The idea is that if you have a build, then determinism will say that if you perform this build again, you'll get the same package. So if you have the package, if you have the hash of the build inputs, and this hash is attached to the package, then you know that if I get build this build input again, I'll get the same package basically.
But what if you don't? Like, what if there's a failure? Like, I mean, you have hashes of the actual package contents somewhere, right? To see that the reproducibility is
at the moment, Nix does not. There's a big push towards having a hash of the build the package content as well, since that would allow content addressing and a lot of nice properties from that. But it doesn't actually work with this hash of the content. Only the hash of the build recipe.
So you're downloading binaries that somebody else has compiled, and you're not.
Sorry, I don't hear anything.
Are there binaries being distributed though? Like you're downloading binaries that somebody else has built?
Yes, you're allowed. You can download binaries, and you use the hash of the build recipe as the key for the downloaded package. And then you're basically, the package can be signed by whoever provides you the package.
Okay, so there they are actually signing their binaries and saying...
it's a signature placed on the package, not the hash of the package content, but sort of the same. So you have to trust who you're getting the package from.
Right.
And that's the thing that why it would be nice to have the content of the package also hashed, since then we can pull the package from anywhere, and then we can just verify that it matches the hash.
Yeah, I mean, it seems like identifying the things in the store using the package, the output hash, which of course would include the input hash also, would be ideal.
Yeah.
I think this is the final question.
What if different build recipes, they touch the same configuration file? How can it merge the changes in some way? Or?
So if I understood you correctly...
So for example, etc. fstab.
Sorry, I don't hear anything. Maybe I'll run over there.
So let's different build recipes. If they touch the same configuration file, a global configuration file, what happens then? Can it actually get merged?
Well, the build recipes are not allowed to have any global state or any side effects. So
what about etc. fstab?
So if you have any kind of global configuration you want to inject into the package build, you actually have to provide that inside the recipe itself. So it's like an argument. So it will become like an argument into this build function. So there's no like hidden variable injected into the build process. And builds are typically done in like a sandbox environment where there's no network access, there's no access outside the build directory, and like the time is set to the epoch 0, like 1970.
I'm not sure you answered precisely that question. If two build recipes touch etc. fstab, can they do that in some way? You had a build recipe that did some changes to fstab, right? And that lived inside the package hashed folder.
Yeah, they'll live inside the Nix store, but the hash will kind of keep them separate, regardless, even if they kind of contain the same paths and everything.
So I think we need to end here, but please big applause for Robert.
Thanks.